Now in this lesson we're looking at equivalent ratios. Now by way of illustration, we'll look at 3/4 as a fraction firstly. Now if we times the top by 2 and the bottom by 2, an equivalent fraction is formed. 3 times 2 is 6, 4 times 2 is 8. So we had 3/4 and we can change it to 6/8. They are an example of equivalent fractions. Now in a similar way, equivalent ratios, 3 to 4, if we times the first one by 2, made it a 6, times the 4 by 2, made it an 8, 3 to 4 is in fact the same as 6 to 8. That is an example of equivalent ratios. Let's look at a few examples. We're asked to complete the ratios. The first one we have 5 to 2, and the equivalent ratio is 30 to something. We need to fill in that something. Well, we can see that we've gone from 5 to 30, and that requires a multiplication by 6. So simply we multiply the 2 by 6, and when we do that, we end up getting 12. Terrific. Example 2, we have 2 to 5 to 8, and it equals some ratio where there's two numbers missing. We know though that part of it is 24, and that 24 matches up with the 8. So the 8 to get to 24 we need to times by 3. So we just make sure that we times each of the other numbers by 3 as well. So firstly the 2. 2 times 3 will give us the 6, and the number in the middle, the 5, times that by 3, and we get 15. Excellent. Our third example, 5 to 8 equals 12 to something. Well, in this case, we're not going to get a whole number involved as our multiplication. Let's look. 5 times what makes 12? Certainly not a whole number, is it? What we need to think of, if we do the reverse, we start with the 12, we divide by 5, and that gives us 2.4. In other words, we must have multiplied the 5 by 2.4 to get 12. So we must do the same to the 8. So if we have 8 and we multiply by 2.4, we end up getting 19.2.